All right, then under post-stratifications, we have found the estimated variance equations 4.14 and 4.15, okay? So first of all, if we look at equation 4.15 or even 4.14, if we compare this estimated variance with a chapter 3 simple random sampling variance, in chapter 3, a simple random sample estimated variance was defined as the final population correction factor multiplied to the sample variance S squared divided by n, right? So in that case, we only have in SRS case, we only have one group from the population. We only collect one sample. So the number of strata is actually equals to 1. Then in equation 4.14 or 4.15, when WL equals to 1, so the second part will disappear, okay? So we see that the estimated variance for the post-stratification is the same as a simple random sampling case. But if we compare the post-stratification variance with the stratified simple random sample under the proportional allocations, okay? So just to recall what is proportional allocations. Proportional allocation, that means in the population, we divide the stratum, and then we collect the data or the number of samples, NL, that is in proportional to the population size, capital NL, in each of the stratum. Okay, so proportional allocations, the estimated variance under the proportional allocations in stratified random sampling is the equations summation of variance in each of the stratum, adding up, weighted by WL square. Okay, expand this, we take out one of the WL, become capital NL over N. Okay, in this case, we are trying to expand this bracket under the proportional allocations. This factor, capital NL over N, is the same as the little nl over N. So this is what the proportional allocation means, right? So the capital WL is the same as the lowercase WL. In this case, we can try to cancel out one of the NL. So in this case, we are not concerning the sample size over the for each of the stratum. Okay, so if we compare the stratified random sampling case under proportional allocation, the estimated variance would be as compared to equation 4.15. So that would be the first part of what we see. Okay, in this case, we see the second non-negative terms in equation 4.14 or 4.15. This is non-negative. So that is the additional amount of the increase in variance using the post-stratification. So if we consider, we first collect the data N from the population, and then after we collect the data, we look at N1, N2 men and women, and then we divide them into stratification methods. So that would be a substantial amount of the variance that we actually adding back into the stratification. That's why it is called the post-stratification methods. This term is usually not too significant if we look at these. Let's look at equation 4.14 or 15, the same, okay? So if this second non-negative terms would not be too bad if we have the sample size N is significantly large enough, because we have 1 over N squared. So make sure that if we are conducting the post-stratification, we need to have N is relatively large so that each of the NL is also large enough, then that would not add up a lot of the variance to our estimated variance. Okay, because if NL is not large enough, each of the sample variance SL would be a bias. The SL may be biased based on very small sample. Okay, and in this case, we can't stratify too much or too finely into small subgroups. Okay, Thirdly, if we want to perform the post-stratification, we need to know the true population size of each of the stratum. So that means NL, we need to have information of it. We can obtain this capital NL from some of the official statistics. We need to know what is the population size so as to adjust for the lead to NL. If we don't have that capital NL, we cannot closely approximate the post-stratification weighting and the estimate. Okay, so it's as a post-stratification should not be used if we don't have the weighting of the populations. We would make a very poor estimate. Okay, when the sample size NL is greater equals to 20, at least have a size of 20, then the post-stratification would be good enough to be used, and we can estimate that using the formula 4.14 for the post-stratification variance. Okay, compare between the Y-bar estimate under stratification under the proportional allocation. Again, the Y-bar under proportional allocations would equals to the summation of each of the stratum Y-bar adding up together, weighted by the weighting, the capital W or the lowercase w, because we are looking at the proportional allocations. Okay, so this is known. You should have known that. Okay, and compare that with the post-stratification method. The post-stratification, we need to follow strictly that we are adding up all of the Y-bar weighted by the population size, but not weighted by the sample size, lead to NL. Okay, so this is very important that under post-stratifications, we must add up all of the stratum Y-bar weighted by the population size. So that's why in point 3 it says that if this is not known, we cannot perform the post-stratification method. Okay, so let's look at this example and you can see that's why. Our example 4.20, the estimated average weight of individual in a large population of 10,000 having equal gender proportion. Okay, and we conduct a sample of 100 and we have the following result. So after we collect 100 data from the population, then we realize we actually collected 20 men, 80 women, and from this sample we have 180 and 110 for the average weight, and we have the sample variance. Okay, so in this case we actually perform a simple random sampling, but we can now obtain the gender information after conducting the interview. So we can consider this as a post-stratification method. Then we can now, rather than to estimate under the stratification proportional allocations, because this is depends on the sample size. So in this case, men are underrepresented in this sample. If you look at that, because we know that under the population, we should have equal gender proportion. So the capital N is actually 50-50 for the proportion. But what happened is that after we conduct the interview, we can't control how many men and women we randomly chose, right? So if that's the case, we collect 20 to 80 in that proportion. This is not proportional to the actual gender proportion in the population. But if we calculate the Y-bar stratification method using a proportional allocations, we might come up with 124 as our estimate. So this would be inaccurate because men are heavily underrepresented in this sample. what we need to do is to adjust that estimate by post-stratification. So rather than using the little omega, little WL, or we use the sample size to multiply it, we need to calculate the Y bar post-stratifications estimate using the population ratio. Okay, so in this case, we were told that they have equal gender proportion, so 50-50% of the Y1 bar and Y2 bar. So in this case, the post-stratified Y bar would be estimated by 145. And again, we consider this as a post-stratification method. Then the estimated variance would equals, we use the equation 4.14. So we calculate the estimated variance based on our equations, and we find that we cannot omit the second part. Although the sample size 100 is relatively large enough, but this part we cannot omit it. We need to include it in the estimated variance. That would be the increase of the amount of the variance using this post-stratification method. Okay, so the estimated variance is about 2.405. All right. Another example, we look at a large firm that we know that 40% of the account receivable are wholesale, 60% are retail. So this is the population proportion from the entire populations for the wholesale and retail. And then what happened is that if we collect 100 samples from the population, we realize that we have collected 70 to 30 or 7 to 3 proportion, which is not exactly the same as the population proportion. So in this case, again, we shall not simply use a stratified random sampling estimate under proportion allocations. We need to look at the Y bar under post stratifications. So the Y bar for each of the wholesale and retail add up should be referring to the actual population ratio. Okay, so that would be 40% of the wholesale multiplied to Y1 bar plus 60% from the retail of the Y2 bar. Okay, and then the estimated variance would, again, we use the formula 14 to estimate it. So you may say that this Y bar estimate under the post stratification, we only obtain that Y1 bar and Y2 bar based on the wholesale 70 number of wholesales is 70 cases and 30 of cases. So Y1 bar and Y2 bar does not fully reflect what should be about for that 40% to 60% of the wholesale and retail, because that's based on 70%. Is not 40%, right? So that's why we have the additional variance that is added to this part, or the increase of the estimated variance. Okay, so I leave you to do the calculations. Lastly, why we do a post stratification, like we mentioned at the beginning, saying that if we don't have full information of the stratum population size, or we don't have the stratum variances, that we can't easily divide them into stratum to know that we have a homogeneous nature or heterogeneous between stratum. If that's the case, we might need to first collect a simple random sample from the population and then divide them into stratification. So that would be a post-stratification. Inability to classify the population elements into appropriate stratum without the actual contact, like the previous two examples, that we do not know some of the gender proportion or the wholesale retail proportion, then we need to conduct the simple random sampling. Then we do stratification. And thirdly would be the handling the non-responses cases, that we will come back to that for the non-responses cases later on in chapter 7. Okay, so that's it for this week, stratification.